Okay, so today we're talking about probability. It's kind of fun stuff. So is order important? That's a question that not every time you do probability, but many times you're going to come across like, is order important? We talked about permutations yesterday. Order is important for a permutation, but combinations, order is not so important. So the official formula for the number of permutations, if it's just a straightforward questions like we had yesterday, like how many different ways can 10 runners finish a race? 10 factorial, right? It's just that's the simple formula you use. And so when it's a simple question like this, how many different ways can the letters of the word math be arranged in a row? So one way to do this problem, by the way, is literally to write out every single possibility. So you could write out M A T H, M A H T. Try to be very systematic about this. I'm going to say T next, A H, M T H A, M. Let's see what I haven't done there. H T A and M H A T. So those are all the possible combinations that start with an M. Let's start with an A here. A M T H, A M H T. A. Let's try T next. M H A T H M. A. C H T M. A H M T. By the way, sometimes you do this enough, you kind of figure out a pattern. We had six of these guys. If I start with, say, T next, how many of those guys do you think we're going to have? If I start with H next, how many of those guys do you think we're going to have? So I'm not going to write them all out here. That would be called the sample space if I did. But I could write out all different, let's see, 6 times 4 is 24. And by the way, could we have just done that with the formula? N factorial is just, that would be what? There are 4 letters. We're putting them in order. 4 factorial would be 4 times 3 times 2 times 1, which is 12 times 2 is 24. There are 24, again, 6, 6, 6, and 6. There are 24 different ways that you could arrange 4 numbers in. So you could actually write them out. You can know the formula. That'd be the fast way of doing that. In this case, order is important. It's a permutation because order is important. Let's try a question that really doesn't have to do with order. And this is a very classic kind of math problem. In senior class, there are 60 students total, not too much different than St. Mary's. 40 take math, 30 take English, and 20 take both math and English. It's kind of unusual, but that happens sometimes. Okay, so this looks like a situation where there's some overlap between two groups. So I'm going to draw, if you remember, if you've ever seen a Venn diagram, so with the Venn diagram, like one of these might be math, and one of these might be English. And so if I do a Venn diagram, I always start in the overlap. So I know it gives me 40 is math and 30 is English, but I really want to start with this overlap group. So there are 20 students that are both English and math. There are 40 students that are math. So the way a Venn diagram works is you're not going to put a 40 here because that would be 60 students. So there's only really 20 that are only math and not English, even though there are a total of 40 in the math circle there. There's a total of 30 in the English circle, so I need 10 that are only English, 20 that are both English and math. So it looks like there's actually a total of 30, 40, 50 students out of the 60 seniors that take English or math. I'm not sure what's happening with the other students, but that's just the situation. Okay, so what's the probability of taking math or English? So that's just a good probability. So the probability, the basic idea of probability, you probably know this. Probability is success you want on top of the fraction divided by the total possible in the denominator. So in this case, our denominator is there are 10 different possible. I'm sorry, not for this one. Sorry, I was thinking of a different problem. So this one, there are, let's see. So we've got a total of 60 students, right? So we've got 60 students. So 60 is the denominator and taking math or English. So I'm really happy with someone who's taking math or taking English. So I'm going to add up all 3 of these cases. So I'm out of 20 plus 20 is 40 plus 10 is 50. There are 50 out of 60. So that simplifies to 5/6 of the senior class is taking either math or English. Probability of not taking math. So this would be, again, our total possible is still 60 here. Not taking math. So I don't want math. So I don't want anything in that math circle. So the only numbers that, well, this is kind of interesting here. So let's look at this holistically. So there's kind of like an outside part here. And you actually have to kind of think about there's actually some students who don't take English or math. There's a total of 60 students. That's only 50 there. There are 10 students. I'm not sure what they're doing, but they're not taking English or math classes. So maybe they're, a special school where they specialize in certain subjects, but seems like a bad plan. You should probably take math and English senior year, but this is the case here. So how many students are not taking math? Well, taking math, there are 40 students. So there are actually these students and these students are the ones not taking math. So there are 20 that are not taking math. Probability of taking math or English, of neither taking math nor English. Okay, so I guess I should say nor probably, nor English. So I don't know. It's a good question. English-wise, y'all can help me out there. Neither taking math or English. So sorry, getting hung up on the language here. So that would be well, there's only 10 students there in that situation. So 10 out of, by the way, this is simplified to 1/3. If you simplify that fraction, this is 10 out of 60 or 1/6. You always want to simplify probability. And finally, the last one would be, again, out of 60 is a total. Taking English, but not math. So there are 30 that are taking English. And those folks are not taking, but not math. Ooh, this is a tough one. So you have to really think about this. Taking English, but not math. Ooh, so there's 30 people taking English, but 20 of them are actually taking math. So there's only 10 that are taking English, but not math. So 1/6. You really have to take a step back and think about some of these. I think it helps to draw out a Venn diagram when there's overlapping information. Sometimes the problem is a little bit more straightforward, like this one is. So let's try this one. So bag contains 5 red marbles, 2 green, and 3. Sorry, they're balls, not marbles. There. Pick one ball from the bag at random. So you've got. I'm just kind of picture it here. You've got 5, 2, 3, 4, 5. There are 5 red balls. There are 2 green balls, and there are 3 of the blue ones. Okay, so there's a total of 10 balls altogether. So in the denominator here, we're definitely going to have 10 to start with. So how many are green? Well, 2 out of 10, which simplifies to be 1 out of 5. That was easy. Not blue. Well, now it's still out of 10, right? But I want to get something that's not blue. So I'm really happy with red. I'm happy with green. So there are a total of 7 that I'd be successful with. So 7 out of 10. Green, but not blue. So 10 is still the denominator. Green or not blue. So I'm happy with green. I'm happy with those 2. I'm also happy with anything that's not blue. So I'm happy with those 2 and I'm happy with those 7. It's kind of like, really, if you look at these 2 problems, we just did probability of green and we just did probability of not blue. So we're kind of putting those together, but you have to be careful with this because there's some overlap. I don't know if you notice this, but those 2 green ones are counted twice. So it's part of the 7 that are not blue, but also part of the 2 that are green. Well, I can't count those 2 twice. So there's really only 7 total that are green or not blue. I can't say 9. That would be 9 out of 10. There's actually, 3 that are in the other category there. So this one would be out of 10, green or red. That's a little bit more straightforward. So green, I'm happy with green. I'm happy with red. So any of those 7 I would be happy with, and that would be 7 out of 10. Let's get into some other ones. Again, the question we're asking behind the question here is order important or not? In this one, how many ways can a committee be chosen from the 3 members of this club? So I don't think order for a committee, you're choosing a committee. It doesn't matter if I choose, you know, A, B, and C or B, A, C, which order I choose those three students in. So really, this is going to be 9, choose 3. Looking at yesterday's stuff, you're going to type that in your calculator, and whatever your calculator says is your answer there. You could do the formula if you want, but I would recommend using your calculator at that point. Whoops, sorry about that. So just to remind you on how to do that, menu, well, you probably should go to Scratchpad first. So menu, probability, that's a combination, and you'd say 9, 3, and that's 84. So 84 is the number of different ways that can happen. Let's try a tougher one, try a few tougher ones. It's kind of fun to do this. Lock has 12 positions, so it's kind of strange. Usually a master lock might have 36 or some more, but locks are different. Then if you've ever had one of these master lock type locks, it goes clockwise first, like it goes to the right, it kind of turns to the right, then you turn it to the left, like counterclockwise, and then it goes clockwise again. If successive numbers in the combination cannot be the same, how many different combinations are possible? So I really make 3 decisions here. You're going to spin it to the right, and you know you've got 12 possibilities times. It's kind of like that slot method we did the other day. The 3 decisions you're making. The next number, successive numbers, cannot be the same. So I can't have. There's really one number, whatever the first number came up as, could have been a 5 or 6 or whatever. I can't have the second number be that same number. So there's only 11 possibilities left for that one. And then you go counterclockwise for that one. Let's say, for example, that your actual digits you chose were 5 and then a 3 when you went counterclockwise, and you got to choose the next digit. So this one's a little tricky here. So how many options are there for the last? A lot of students will say 10 here, but actually the next digit can be anything except it can't be the digit before. It can't be a 3, for example. So really it can be all but one number here. So whatever 12 times 11 is in your calculator. So 12 times 11, whoops, times 11 times 11, 1452. So there are 1,452 different combinations. So if you didn't have someone's locker combination for this, you could keep trying and eventually you would get there. Kind of fun. Is order important? So 20 raffle tickets in a hat, 4 tickets chosen at random. The holders of the winning tickets are to be awarded free trips to the Bahamas. How many ways can the 4 winners be chosen? So this is kind of like, you know, you win. So it doesn't really matter if you're chosen first or last. So in this case, this is going to be 20, choose 4. This is a combination. You know, this is really, from what I understand, some of you might watch The Bachelor or The Bachelorette. After each round, like I think the person gives out roses. It doesn't really matter if you're the first row or rows or the last rows, you advance to the next round. In this case, it doesn't really matter if you're the first ticket chosen or the 4th ticket chosen, you get the prize. And so order is not really important. There might be some strategy of The Bachelor, but really everyone advances or everyone gets the prize. So order is not really important in this particular question. But here's another raffle. Wow, another raffle. 4 tickets are selected in order. The holder of the first ticket wins a car, the second one a motorcycle, the third one a bicycle, and the 4th one a skateboard. Well, now I think order is important here because I'm guessing you'd want to win the car rather than the skateboard here. So order is important. So this would be 20 P4 here. And so you'd get your calculator out here and type in, so you go to, again, menu, probability, permutation, and it'd be 20, 4, which is 116,280. 116,000, that's a lot, 280. Permutations really get to be big numbers very quickly. By the way, the other way you could have done that is by the slot method. So permutations can always be done with the slot method. You could always just multiply them out. So you'd have 20 options for the first, but once the first ticket's chosen, there's only a few tickets left, so 19, 18 to 17, and that should work out to be the same.